About 4 years ago, I started designing an automatic turntable and then kind of went on a long hiatus. But lately, I've had some more time, so I've been wanting to get back into the project. Over the course of the development of this turntable, I released 2 videos showcasing 2 totally different parts of development. The first of which I showed on Reddit, where it could only play 7-inch records, and in the other, I had made it able to play all sizes. Now, when I left this project off, there were a lot of problems with it that I hadn't solved yet. But coming back to this with a fresh pair of eyes, I kind of have some ideas of how I might go about solving some of those problems. But before we get into that, we need to go all the way back to the beginning and see how did this project even start and how did it end up at the end where it was. Because I'll be honest, it kind of ended up in a little bit of a disaster, but at the beginning it seemed really straightforward. So if it seemed fine before, then what happened at the end? Let's roll that intro and let's see how that panned out. Like all projects, this one started out with a vision. Since I was a kid, I've always favored 7-inch 45 RPM records over LPs, and I've always had a fascination with those RCA 45 record changers. In fact, the RCA 9JY and 45J2 you see here, those are 2 of my favorite turntables ever. Even though they're really not the highest quality, it's just a lot of fun to put a bunch of beater 45s on them and listen to them, and hear music I would have otherwise never heard before. But back to the automatic turntable, that's kind of the idea that I had in my head for maybe what I wanted this to look like. Maybe minus that specific record changer mechanism. I mean, it's cool, but not really what I was looking for in this project. Speaking of which, what am I looking for in this project? I had a solid set of bullet points for what I wanted this turntable to become, and above all, it's just going to play 7-inch records, either at 33 1/3 RPM or 45 RPM. Like I said before, I'm basically modeling this off of a 45 turntable from the 50s, so this will be fine. I also wanted to have the potential for future expansion to full-size LPs though, so this would be like designing the motherboard to be able to support multiple sizes. I also wanted it to have a built-in communication port that expansion hardware could be plugged into, and some of these might be, for instance, a record changer, an alarm clock, remote control, an interface to allow control from a Commodore 64, because why not? I also wanted it to have automatic capabilities. So you press the start button, the Tonearm sets down on the record, and then at the end of the record it picks itself up and puts itself away. And I want it to be made from parts that can easily be made or easily be found. So I've been trying to build this with entirely off-the-shelf parts and keeping all of the PCB designs and everything open source, because if someone else wants to decide to build a turntable like this in the future, I mean, the resources will be there. And of course, I wanted it to have some basics: anti-skate, speed control, wanted it to track lightly, 2 grams or less, because I want this to treat the records nicely as opposed to most other record changers you know of. And yeah, that last point, that's one of the most important. Above all, I really wanted this to be an automatic record player that I could play my good records on, especially with the changer mechanism. Those 45 turntables that RCA made, they're really cool, but I wouldn't put my good records on it. But this is something that I really wanted to be able to put a bunch of good records on and have it play through all of them, both sides. That was the vision anyway, but you could see I didn't exactly get that far yet, but that's not to say we won't get there with this new attempt. And no, I'm not pointing to the new attempt. In fact, this is the last revision before I canceled the project. Now, with a vision in mind, I had absolutely no idea where to start, so I just started making a prototype on a pizza box of approximately the size I thought the turntable might be, and I got to work on that. And this is what I came up with. It's a pretty simple design with a platter, a Tonearm, home play and pause buttons, and a 3-way switch. Now, once I got this down, I moved to the part that I found to be most interesting, which was the automatic movement, of course. Now, throughout this project, I called the main piece of the automatic movement the Tonearm movement hub, which you can see the first 2 iterations of that here. The first thing I started out with was vertical movement, because I figured that would be easier of the 2 axes. I modeled the Tonearm lift component off of the standard type of Tonearm lift you typically see on turntables, Not too original, but hey, if it ain't broken, don't fix it, right? The internal mechanism consists of a stepper motor that moved a linear gear into an upper or lower limit. I opted for a stepper motor for this to account for the possibility of failure. For example, if we know that it's supposed to take about 300 steps to make it to the upper limit, but we're at 500 steps, we'll know something got stuck and we need to stop the movement to prevent damage to anything. And you can see this happening here with this flashing yellow LED. That indicates that the pause command, whether raising or lowering, failed to make it all the way to its destination. And yeah, that's basically how vertical movement worked. Like I expected, this part didn't end up being too complicated, but the part that I was really kind of fearing was the horizontal movement. So that's what I moved to next. Designing the horizontal movement mechanism was big and scary to me, so I started off with something just a little bit simpler, the horizontal positioning sensors, which these are essential to the horizontal movement, but they're a lot easier to figure out how I'm going to use them. My original idea for this was to have 3 discs that would trip 3 optical sensors. The top one indicated the home position, the middle indicated the 7-inch outer edge position, and the bottom one indicated the pickup position. Next, I worked on a mount for the horizontal stepper motor. There's a gear on this motor, and another gear that would swing back and forth to connect the motor to the Tonearm shaft. This model was just a proof of concept. I had to manually engage and disengage the gears, but this at least showed me that I was on the right track. I finished this up by adding a solenoid to push the gear into place when movement was desired, which would also retract the gear when the Tonearm needs to move freely. By this point, I'd also developed a counterbalance weight, as well as slots for the cartridge to mount to. I also started the beginnings of the user interface buttons. Hooked up to the Arduino Uno, everything kinda looks like a mess, but the important part is that it seems to be working. Still a few imperfections. As you can see, when the horizontal gear disengages, it moves a little bit further than its target, but it's mostly there, I guess. And you can also see I did away with the horizontal positioning discs I showed earlier. I ended up going with mounting the sensors at specific positions that a rocker arm would trip. And this rocker arm follows the movement of the Tonearm 1-to-1, so it's kind of like a mini Tonearm within the turntable. Very, very bulky, but it worked. Here you can see the rocker arm sticking out the side of the mechanism, while the Tonearm sits in home position. And yeah, at this point, horizontal movement seems to be working. I mean, it picks up and it puts down. What more could we want from it, right? So, let's move to the turntable next. Now, as far as I was aware, the turntable was the last part that I needed to design and figure out what I was going to do, and I thought this was going to be the easiest part. So, it should just be smooth sailing from here, right? Anyway, I started by mounting my automatic Tonearm mechanism to the prototype box I made before, and placing a record where I thought it should go in relation to the Tonearm. And I followed that up with completing the turntable assembly. Yeah, I didn't document this part too well, but I guess I also added a 7-segment display to the prototype as well, and this would monitor the turntable's speed. You'll notice I used a really long rod in the center of the turntable. Interestingly, this is the only size I could find that matched the center hole diameter of a standard record. But also, unfortunately, I couldn't find a proper bearing size for it, so I attempted to rectify the diameter difference with electrical tape. The results weren't great, but this at least offered a good starting point. Now, the mechanism worked by having a motor mounted to the back of the turntable assembly, and this would turn the turntable with a belt. The little disc with flaps directly under the turntable is what would interrupt the speed sensor, calculating the speed 8 times per rotation. At this point, the turntable is fully functional. It would, pretty reliably, set the Tonearm down in the correct location, and totally reliably pick up at the end of the record. The turntable speed fluctuation was pretty questionable. But it did technically work and functioned as a good starting point, ready for improvement. Now, during the development of this, there were a ton of wires going to all sorts of places on this turntable, and it was becoming a pain to figure out where everything's supposed to go. Things would come unplugged all the time. So I figured it was time to design a PCB, and that's what this is. This is the PCB that drove the turntable in the video that I posted to Reddit. Now, I'm not going to go into schematic specifics with this board because I just don't have an easy way to get the files for this particular version of the PCB, But we can take a look at the board itself to get a good feel for its layout. Now, I'll just come out and say, this board is a mess. This is the first time I ever designed a PCB, and it has all sorts of questionable practices. And I chose to go with all through-hole components, so it turned out a lot larger than it should have. Oh yeah, and I also didn't utilize the input pull-up feature the Arduino offers. I used pull-down resistors for all of the input pins, even when I didn't need to. Starting at the bottom left, this board took a measly 5 volts of DC. I added a few extra pins to expose additional 5-volt lines, as well as a 3.3-volt line, just in case I needed it for another part of the project. To the right, you'll find ports for the power switch, 33 RPM adjustment potentiometer, 45 RPM adjustment potentiometer, as well as the speed select switch. This would allow the user to select 33 1/3 or 45 RPM and adjust these values to their liking. Further to the right, we have the turntable's motor plug. For this motor, I picked the cheapest one I could find on Amazon. It had a built-in voltage regulator with 33 and 45 options, though I had it jumpered to its max speed setting all the time, which they advertised as 78 RPM, so I could just adjust it with my own potentiometers. This implementation was problematic, but I'll mention that in a little more detail later. The status LEDs all shared one port, consisting of the power, an unused pin called turntable power, which would have lit when the turntable is supposed to be spinning, and the pause/movement indication LEDs. Despite this version only supporting 7-inch records, I wanted the board itself to be able to support 7-inch, 10-inch, or 12-inch records. This is just so down the road, if I decided I wanted to upgrade this to be a full-size turntable, I could do that. In the top left, this is where I designated the calibration potentiometers. These would get used to adjust the Tonearm set-down positions for each record size. The top right corner is where I had all the ports for each sensor and limit switch. This included the speed, pickup, home sensors, vertical positioning limit switches, and user interface buttons. In the very top was the control port, which would have been used to plug those attachments into the turntable that we went over earlier. Now in the middle, this is where things get a little more complicated. You see, I needed way more pins than this Arduino offered. This was an Arduino Nano Every, and it was one of the cheapest ones they had. So my thought process was, I'm going to use these for the project because they're cheap and they're plentiful. You can even buy lots of 3 of them on the Arduino site. How cool is that? But, like I said, I needed way more pins than this Arduino offered, and rather than look for a different microcontroller with more pins, like a rational person would have done, I added a 16-channel multiplexer that granted me an additional 11 pins. Now, if you're unfamiliar with what a multiplexer is, it essentially lets you control more pins with less, at the cost of performance. In this simple example, say this line is feeding into the Arduino, and these two lead to buttons that the user could press. If my select value is low, then this pin gets read. If the value is high, then the other one gets read. Now, for bigger multiplexers, as you increase the number of select pins, your input pins also increase. So 2 select pins would get you 4 inputs, 3 select pins would get you 8 inputs, and in my case, 4 select pins would get you 16 inputs. So I was essentially able to read the value of 16 pins while only sacrificing 5 pins on the Arduino. So that got me a lot more freedom with what I was able to do. One of these pins was dedicated to the multiplexer's output, which fed into the Arduino input pin, and the other 4 pins were the select pins. If you're curious how performance is hurt in this approach, typically you're able to read a value with one operation. You just pick the pin you want to read and you read it. But in my case, I had to set 4 select pins before I could read that one value, so one read would turn into 5 operations. So you can see how this might not be the most performant. Fortunately for my case, you really didn't notice it because the performance isn't that essential. It's just reading some user input values, nothing that's crazy time sensitive. Now I did a similar thing to the stepper motors, so that rather than have those take up 8 pins, I had an analog demultiplexer split them up so they only took 5 pins on the Arduino. One of these pins would select which motor I wanted to use, and the other 4 would drive the selected motor. Now to satisfy my original vision of this project, the only thing that needed addressed was the turntable speed. It sounded hilariously bad, like completely unlistenably bad, but that's all that it needed yet. It was almost there. My first attempt at rectifying this was to tweak the turntable assembly models a bit. I added a pulley to step up the gear ratio so the motor could spin faster, since lower speeds are what caused the most problems. I also changed to using a shaft that actually fit the bearings I was using, which meant that the turntable's center now had to be 3D printed. But how did this work? That's the real question, isn't it? Yeah, that totally sounds like a terribly maintained 8-track player. And at this point, I'd hooked up the motor to its full 12 volts too, so it wasn't being underpowered anymore. The main problem ended up being that my tolerances weren't tight enough for the pulley, and I had one of the belts way too tight. So at least it wasn't anything catastrophically wrong with the design. In fact, once I fixed the tolerances, we were at the exact point that the project was when I initially posted it on Reddit in 2022. Now, despite this, the turntable's speed wasn't perfect. It was better, it was listenable, but it wasn't perfect. It would slowly rise in speed over time. Like, it might start out at 45 RPM, and then by the end of a record, it might be at 47 RPM. So there's clearly still a problem there. And I know this because my good turntable that's in the other room over there, it doesn't do this. So I would also like this one to not do this. But with this addressed, that speed was still the only thing that actually needed addressed with this. Everything else worked to my satisfaction. It was working fine. It's just this speed was giving me some trouble. Now, I'll go into a spoiler. I did eventually figure out that my rising speed was caused by not using a voltage regulator. So that problematic design I mentioned before with skipping the motor's built-in voltage regulator, yeah, that pretty much contributed to my problem. But I couldn't use this anyway because I wanted to use my own potentiometers to control the speed. Skipping that for now though, one of the last things I added was anti-skate, and this was easy enough to do with stainless steel weight, some fishing line, and a paperclip. It's only a prototype anyway. After that, the 3D printed parts just needed to be remade in other materials, and I planned on having a metal shop turn the turntable out of metal, and I planned on bending an aluminum tube to use for the Tonearm, among other changes. Basically, I didn't want any 3D printed parts visible, except for a few parts related to the Tonearm. And the parts that had to be 3D printed, I was thinking maybe I could make them out of ABS and smooth them with acetone fumes. I'd seen some pretty promising results with those in other projects that people have done. Nothing that I've tried though, but I was certainly willing to give it a shot. Now, I had a lot of plans for where I wanted this project to go, and I had a lot of ideas, but none of them ever happened, because I thought to myself, why limit myself to only be able to play 7-inch records at 33 1/3 and 45 RPM? Why not play all speeds, all sizes, right out of the gates, everything? Well, that's what I wanted to do then. So now that I had this version working, I thought, well, before all the problems are solved, why don't I just add all this other stuff onto it? So then that's what I did. I tried to make it do everything. And to be honest, this is what I should have done from the start. I should have planned it from the beginning, having all sizes and all speeds available, but I didn't. And I suffer the consequences of this when I tried to implement these features after only implementing the 7-inch ones. But we're going to stop right here before this video gets too long, and we're going to talk about that in the next video, where I'll go over some of those additional designs where I was able to support all of those speeds and sizes, and we'll see where that went wrong and where scope creep came in, and just a whole lot of poor design choices. And maybe a little bit into how I plan to solve some of those problems, because I do have some ideas for how we're going to solve these. And of course, I plan to continue this project, so I better have ideas. Though this turntable looks essentially like a turntable down here, I don't know how much of it you can see in the camera shot, but it's here. It doesn't work though. But we're going to make a version that wouldn't have been able to exist if this hadn't first existed. So, thank you for watching, and I look forward to seeing you in the next video.